Hi everyone, this is Mrs. Snowbeck. Today we're going to do Unit 3, Lesson 4, and we're going to learn how to graph tangents and cotangents. So hopefully by the end you can say you can graph cotangents and tangents, and that you can graph the transformations of tangents and cotangents. Recall from previous lessons that tangent is equivalent to sine over cosine, or in other words, the y-coordinate over the x-coordinate. And then also recall that cotangent is the same as 1 over tangent. So imagine 1 over tangent x. That's the same as 1 over sine x cosine x. But you don't want to leave a fraction in a fraction, so multiply by the reciprocal. Whatever you do on the denominator, also do in the numerator. So on the bottom, these cancel, and then on the top, we end up with cosine x over sine x, which is what we have here. So cotangent is cosine over sine, which is basically the x-coordinate over the y-coordinate. Let's think about the unit circle. Remember the unit circle, the coordinate over here is at 1, 0. Coordinate up here at pi over 2 or 90 is 0, 1. The coordinate over here at pi or 180 is negative 1, 0. And the coordinate down here at 270 or 3 pi over 2 is 0, negative 1. And then I also want you to think about the 45, or this is also pi divided by 4. The coordinate there is root 2 over 2, comma, root 2 over 2. And so therefore down here, if we go down negative pi over 4, the coordinate down there is root 2 over 2, comma, negative root 2 over 2. Remember, pi over 4 is the same as 45 degrees. So let's think about the tangent values let's start with negative pi over 2. Negative pi over 2 is the same as negative 90. So we're going to go down, I'll just highlight it, down to this spot. And we're going to think about tangent. Well, tangent is really y over x. So the y value there is negative 1. The x value there is 0. Negative 1 over 0, can't have it, undefined. Let's think about the tangent value at negative pi over 4. Well, remember, tangent is y over x, and so we're going to have negative root 2 over 2 over positive root 2 over 2, which is negative 1. At 0, let me just highlight it right here. Think about y over x. It's going to be 0 over 1, which is 0. And at positive pi over 4, we have root 2 over 2 over root 2 over 2, if we do y over x, which is 1. And then at pi over 2, which is straight up, that's the same as 90 degrees. Y over x is 1 over 0, which is undefined. Now, remember, when we run into those undefineds, that's when we're going to get our vertical asymptotes. So at negative pi over 2, it's undefined, and so I'm going to draw in a vertical asymptote. And same thing at positive pi over 2. And now we're going to repeat that, and it looks like it's every 1, 2, 3, 4 boxes. So every 4 boxes, I'm going to repeat that, which is every pi. If you can remember, every 4 boxes is really equivalent to pi. So 1, 2, 3, 4. Here we go at 3 pi over 2. And then 1, 2, 3, 4. Here we go at negative 3 pi over 2. There are the vertical asymptotes. Now let's place some of our other points. So we have a point at negative pi over 4, negative 1. And where am I getting those numbers from? Right over here. Negative pi over 4, negative 1. So I'm going to go to negative pi over 4. I think I'll just count by 1. So this is negative, or count by halves, excuse me. So that would be right here. Negative pi over 4, negative 1. Then I have one at 0, 0. And then I have one at positive pi over 4, positive 1, so right up here. And then I have the vertical asymptotes. So what happens to your graph is it's going to go like this. It's going to approach those vertical asymptotes but never touch. And then we just repeat that look. We repeat that pattern. And so in the next group here, it's going to look like that. And here we're just going to have like half of the little graph. And we repeat over here. And we repeat over here. And there it is. That is the graph of tangent. And so think about the period. How often does it repeat? Well, it's every 4 boxes, which is pi. What's the domain? How far left and right does it go? Well, kind of goes forever, but it has these spots where it can't go. And so the domain is all x values such that x cannot equal some things. So the first positive spot that I see is at pi over 2. And so it cannot equal pi over 2. And then it's every 4 boxes after that that we get a vertical asymptote, which is multiples of pi. So plus n times pi, or any multiple of pi, where n is any integer. How about the range? How far up and down does it go? It goes forever, so it can go from negative infinity to positive infinity. Now let's try to graph y equals cotangent x. Remember, cotangent is really cosine of x over sine of x, which is really the x value over the y value. So at 0, think about x over y. We're going to have 1 over 0, which is undefined. At pi over 4, we're going to have root 2 over 2 over root 2 over 2, which is 1. At pi over 2, if we do x over y, we're going to have 0 over 1, which is 0. At 3 pi over 4, which is over here, think about your coordinate there. It's going to be negative root 2 over 2, comma, positive root 2 over 2. So if we do x over y, it's negative root 2 over 2 over positive root 2 over 2, which is negative 1. And then at pi, which is over here, if we do x over y, we have negative 1 over 0, which is undefined. Remember, those spots where it's undefined are your vertical asymptote. So at 0, I'm going to draw in a vertical asymptote, and then also at pi. And we can repeat that every 4 boxes or every multiple of pi. So 1 pi, 2 pi. Okay, there they are. Now we're going to graph our other points. So we have our first point goes at pi over 4, 1. So pi over 4 is between 0 and pi over 2. Let's just count by ones here. So here's 1 and negative 1. So pi over 4, 1. Then pi over 2, 0. Then 3 pi over 4 at negative 1. And then we hit those vertical asymptotes. So remember, it has to approach those. So you kind of do like a little snake through there. And then repeat. So I just put similar dots or points in each of these intervals. And I connect them with kind of a smooth curve. And that is the graph of cotangent. So then what's the period? How often does it repeat? Well, it repeats between 0 and pi, so the period is pi. The domain, how far left and right does it go? Well, it goes kind of forever. So it's x such that x cannot equal wherever the vertical asymptotes are. Where are the vertical asymptotes? Well, the first one's at 0, and then we add intervals of pi, 2 pi. So it's basically pi times n, where n is any integer, any multiple of pi. What's the range? How far up and down can it go? Well, it can go forever down and forever up. So the range is from negative infinity to infinity. So remember what this looks like. It kind of starts on the left and curves its way down to the right. That's opposite of what the tangent graph looked like. If I do a little sketch over here, the tangent graph looked like this, where it started down on the left and worked its way up to the right. So try to remember that. Try to remember that tangent starts on its left and works its way up to the right, and then cotangent starts on the left and works its way down to the right. I also want you to think about the asymptotes. On tangent, the vertical asymptotes went at negative pi over 2 and positive pi over 2. They kind of straddled the y-axis. Where with cotangent, the vertical asymptotes go right at 0 and pi and 2 pi. So if you can remember that, that's helpful as well. So let's recap what we just talked about, and let's also talk about what happens if we have a transformation. What if we have some numbers in there? So what if we have something like y equals a tangent bx, or y equals a cotangent bx? There's some extra things in there. There's an a in there and a b in there. What do those things do? Well, first of all, the period is affected by the b. So the formula for a period is going to be pi divided by whatever b is. So your first step is going to be locate where are those vertical asymptotes. Remember, for tangent, they're usually at negative pi over 2 and pi over 2. And for cotangent, they're generally at 0 and pi, those first vertical asymptotes. So b is going to affect that, and we're going to have to figure out where our new asymptotes go. Second, you're going to sketch in those vertical asymptotes. So next you would put in your dotted lines at the first two vertical asymptotes, and then however far apart those are, you would count over and put in all the rest of the vertical asymptotes. Now, you're going to divide that interval, or that period, into 4 parts. And a quarter of the way over, you're going to put your first point. Midway over, you're going to put your second point. And then 3/4 of the way, you're going to put your third point. And then finally, connect them with a smooth curve. Number 3. So here you can see we have y equals tangent 2x. Think about y equals a tangent bx plus d. Okay, think about that. The b is the 2. And period is affected by the b. Period is pi divided by b for tangent and cotangent. And so pi divided by 2 is going to be our period. Does it reflect over the x-axis? Well, a would affect that. And so in this case, we just have nothing in front of the word tangent. It's like a 1, so there's no reflection over the x-axis. Is there a vertical shift? That would be if there's a d. There's not. There's nothing floating around back here anywhere. Is there a vertical stretch or shrink? No, because a is 1. And is there a horizontal stretch or shrink? Yes, there is. This time, remember, instead of our period being pi, our period is pi over 2, so it's shrinking by a half. To start graphing, you first need to place the vertical asymptotes. So you have to figure out where are they going to be. Normally, for tangent, they would be at negative pi over 2 and positive pi over 2. So we have to figure out, because the period changes, what happens to those. And so I'm just going to make a note here. To find 2 adjacent, means right next to each other, vertical asymptotes. Recall that normally one of your vertical asymptotes goes at negative pi over 2, and your next one for tangent goes at positive pi over 2. This is where they normally are for tangent. So what you got to do is you have to think, all right, use this little formula, bx equals negative pi over 2 and bx equals positive pi over 2, because negative pi over 2 and positive pi over 2 are where they normally go. Now plug in your b. So we have a 2. So it's going to affect where these go. So if I plug in a 2 for b and now solve it for x, so divide by 2, these cancel. To get rid of that fraction in a fraction, we're going to have to multiply by the reciprocal. These will cancel, and you're going to end up with negative pi over 4. That is the location of one of your vertical asymptotes. Let's find the other one. Normally it's pi over 2. Plug in your 2. Solve for x. So you have x equals, think of this as 2 over 1, multiply by the reciprocal. These cancel, and you have pi over 4. So because we had a horizontal shrink, our vertical asymptotes, instead of going at negative pi over 2 and positive pi over 2, are going to go at negative pi over 4 and positive pi over 4. There are our first two vertical asymptotes. Now we're going to repeat that. So it looks like every two boxes we have to repeat. So we draw those in. And yes, I want you to fill in the whole graph. I want you to graph the whole, everything you can see here, I guess, is what I'm trying to say. All right, so there's all the vertical asymptotes. Now, remember, we're supposed to take that interval and divide them up into quarters. So I'll just use yellow here. Let's go here, here, here. If I divide it into these sections, then I kind of have 4 different little sections within those vertical asymptotes. For tangent, we normally start on the left and work our way right. And we're not going to have any reflections or a vertical shift or vertical shrink. So I'm just going to put this at -1 and this at +1. And so what I do is I put my first dot here 1/4 of the way, my second dot here halfway, and my third dot here 3/4 of the way. Connect. And there we have it. That's the beginning. So it looks like a typical tangent curve where it starts low on the left and works its way high on the right, and then repeat. So we're kind of going, we're going at the half steps between the grid marks. And I just have to fill in all the rest. So go ahead and fill in yours as well. And you want it to be a smooth curve, and you want it to approach those vertical asymptotes but not touch. Takes a minute, but you have to do it. Fill in the whole thing. And there we have it. Cool. It looks busy, but that's it. So remember, y equals a tangent bx plus d. Kind of keep that in mind. And I want you to also remember this, that the period for tangent and cotangent is usually pi, and the period for sine and cosine is usually 2 pi. So let's just kind of keep that in our mind. Now, for periods, remember, we're going to use a different formula here. We take the pi and we divide it by b. The normal period is pi, and in this case, we have to divide it by 1/2. So pi divided by 1/2, if we multiply by the reciprocal, these cancel, it's going to be 2 pi. So 2 pi is our period, which is bigger than it normally is for tangent and cotangent. Does it reflect over the x-axis? Well, a is negative. There's a negative there. So yes, it's going to reflect over the x-axis. Is there a vertical shift? That would be the d, and there's no d floating around, so I'm going to say no. Is there a vertical stretch or shrink? Yes, the amplitude or the a is -3, so this is going to stretch by 3, the absolute value of that. Is there a horizontal stretch or shrink? So normally the period for tangent is pi, but in this case our period is 2 pi, so it is going to double. It's going to stretch by 2. Next, we have to think about where our vertical asymptotes go. For graphing, the first thing you have to do is find your vertical asymptotes. All right, now remember, we're going to think about where are our vertical asymptotes normally for the tangent. Well, we're going to use a formula bx equals -pi/2. That's where the first one normally is. And bx equals +pi/2, because normally for tangent, the first two are at -pi/2 and pi/2. Now plug in your b. In this case, it's 1/2. So we're going to go 1/2 x equals -pi/2. And also 1/2 x equals +pi/2. And we're going to solve each of these. So divide by 1/2. These will cancel. And then over here, you have to multiply by 2/1, by 2/1. these cancel, we get negative pi, or negative pi over 1. And then here, divide by a half. These cancel, and x equals multiply by 2 over 1, 2 over 1, these cancel. So it's pi over 1. So our vertical asymptotes this time are going to be at negative pi and positive pi. So I'm going to draw my first one in and my second one in. This kind of makes sense because normally they're at 0, or normally they're at negative pi over 2 and positive pi over 2, and they're 4 boxes apart. Well, here they're 8 boxes apart. All right, I don't think I can fit any more on this graph because they'd be, you know, if I count over 8 boxes, I'd be off the graph. So next I want to think about placing my 3 dots, and I have to divide this into 3 sections. So I'm going to, or 4 sections. Here's 1, here's 1, here's 1. So notice how I took those 8 boxes, and every 2 boxes I separated them. So I kind of divided them into fourths. 1, 2, 3, 4, right? So now I need to place my first 3 points. Well, I have to consider my A. I have a negative 3 there, which is going to reflect it over the x-axis, and I have a stretch of 3. So normally what would happen is I would start down here at negative 1. Let's just call this negative 1 and positive 1. And I would come up to here, and then I would come up to here. And I would work my way from the bottom left to the top right for tangent. But since I have to have a stretch of 3, I don't think, I actually have to start at negative 3, and that would be off my graph. So I don't think counting by ones is the best idea, or by halves. I think I should count by ones. So let's just make this negative 1, negative 2, negative 3, positive 1, positive 2, positive 3. So I know I have to stretch it by 3, so I'm going to start down at negative 3, but I have to reflect it over the x-axis. So actually, instead of starting down below, I'm going to start up above. I think that's where my first dot goes. My second dot would go at 0, 0, because there's no vertical shift. We don't have a D, we're not sliding it up or down. And then my third dot would go here, and I would connect them with a smooth curve, and this is what it would look like. So let's recap this a little bit. Normally tangent starts on the lower left and works its way up, but we had to reflect it. Instead of starting down here at negative 3, we had to start up above at positive 3. And we had to stretch it by 3, right? So instead of starting at 1, we started at 3. Let's talk about cotangent. So this time we have y equals a cotangent bx, and then you could have like plus d. So normally the period is pi. So to find our period, we're going to take that and divide by b. What's in the b spot? It's a 2. So pi divided by 2. Pi divided by 2 is our period. Next, think about, does it reflect over the x-axis? Well, that would be if the a is negative. And in this case, it's not. We have a 1/2 there. It is not negative. So it's not going to reflect over the x-axis. Is there a vertical shift? Yes, it's going to go down 1 or negative 1. You can see that floating D back there. Is there going to be a vertical stretch or shrink? Well, normally our period for tangent and cotangent, normally the period is pi. Let's just make a note of that. So for tangent and cotangent, the period is normally pi. And then, let me just erase this little arrow. The other thing I want you to remember is for sine and cosine, the period is normally 2 pi. That's something important to keep straight when you're graphing these things. So is there going to be a vertical stretch or shrink? Think about the amplitude. We have a 1/2 in front. So I'll just circle it right here. We have a 1/2. That will affect the vertical stretch or shrink. So we're going to say yes by a 1/2. And then is there a horizontal stretch or shrink? And also, we have a number here. We have a number 2 there. And so again, you have to think, what is that doing to the period? Well, instead of our period being pi, it's pi over 2. So we're going to shrink by a half. Normally it's pi, but now it's pi over 2. Next, let's find our first two vertical asymptotes. So think about cotangent. This one's a little different. So I'll just write this down. Find vertical asymptotes. This is our toughest job, I would say. Well, normally our first asymptote for cotangent is at 0, and our second one is at pi. That's where the first two vertical asymptotes generally go. So in this case, plug in your b. We're going to use that formula, bx equals, and then we use our normal asymptotes, which are 0 and pi. So b in this case is the 2. So we're going to go 2x equals 0 and 2x equals pi. And we're going to solve both of these. Divide by 2, x equals 0. Divide by 2, x equals pi over 2. These will be the first two vertical asymptotes. So at 0, we're going to put a dotted line. And at pi over 2, we're going to put a dotted line. And then we're going to repeat that, it looks like, every 2 boxes. Yep, you got to fill in the whole graph. Next, I want you to think about your midline. This is going to have to shift down 1. And so instead of the midline being at 0, let's just count by halves. Let's say this is at -1 and this is at +1. If I need to shift my midline down 1, the midline will end up being down here at y equals -1. Now, divide each period into quarters. So I'm going to divide it like this with these yellow little tick marks. I'm going to divide it into fourths. So I had to put 3 tick marks so that I get 4 sections. You're not reflecting over the x-axis. You did shift down. You need a vertical shrink by a half. So normally, for a cotangent curve, you would start above the midline by 1. We're only going to start above the midline by a half. Then we're going to come down and work our way to the right. And so, remember your asymptotes. You're approaching them but not touching them. I believe this is what our first section of the graph would look like. It has a shrink by a half. So instead of the dots being, vertically apart by 1, they're only vertically apart by a half. The period shrunk. Now everything's happening between 0 and pi over 2 instead of between 0 and pi. I think we did it. So finish off your graph. Go ahead and pause the video here and finish filling in the sections. And there it is. This is approximately what it should look like. Last one. Will you guys pause the video, try this one on your own, and unpause when you're done? So let's talk about what we found here. We found the period by doing the normal period, which is pi, and dividing by b. Now the b is right in front of the x, which in this case is a 1. So pi divided by 1 was pi. So the period is still the same. Does it reflect over the x-axis? Well, you have to look at the a. The a right here is -1. The negative means yes, it will reflect over the x-axis. There is a vertical shift because of this 3. This 3 is the d. Normally, we could rewrite this y equals negative cotangent x plus 3. The 3 could be in the back, so it is a shift up of 3. Is there a vertical stretch or shrink? Vertical stretch or shrink would be from the a, which is right here. It's -1. And so the 1 will not make it stretch or shrink. The negative makes it reflect, so that doesn't matter. Is there a horizontal stretch or shrink? Well, normally the period for cotangent and tangent is pi, and it's still pi. So no, there's no horizontal stretch or shrink. So next would be to figure out your vertical asymptotes. For cotangent, let's think. Let's just make vertical asymptotes. Normally for cotangent, our first one is at 0 and our second one is at pi. So plug in your b. In this case, right in front of the x here, b is a 1. So we're going to have 1x equals 0, divide both sides by 1, x equals 0. And plug in a 1 again for your b, 1x equals pi, so x equals pi. This makes sense to me. Our period didn't change, so our vertical asymptotes shouldn't change. They should still be at 0 and pi. Draw those in. Looks like it's every 4 boxes. Cool. Next, I think about the midline. We have to shift up 3. So I'm thinking we better count by ones. This can be 1, 2, 3. This can be -1, -2, -3. And our midline has to shift up 3. So instead of being on the x-axis, it's going to be way up here at y equals 3. Now, divide that into 4 sections. So we're going to divide here, here, here. And you're going to place your 3 dots on those hash marks or those tick marks. Is there a vertical stretch or shrink? No. And so normally they would be 1 above and then right on the midline and 1 below. So we're going to stick with that. So wait a minute, we have to reflect over the x-axis. Instead of starting 1 above, which we normally do for a cotangent, we're going to start 1 below. So it's going to start 1 below the midline, on the midline, and then 1 above the midline. And when we draw it in, we make a smooth curve, and it looks kind of like that. And then finish drawing in the rest of the intervals. Here's what it should look like. Remember, we want you to be able to do these in your head. Could you use your calculator to check your answers? Absolutely. But again, normally in a normal year, we would want you to be able to think through these and sketch them out by hand. That wraps up Unit 3, Lesson 4. So you guys are now going to do Unit 3, Practice 4. And if you get stuck, let us know. Have a great day.